Hey guys, this is test 62 game 1. This is the appointments game. We've got 6 appointments here, G, L, P, S, T, and W, and we are placing them in order from 1 through 6 on the 6 different days. So this is an ordering game because the days, of course, have an inherent order. Now I've laid out a bunch of stuff here, but I'm going to explain all of that. We've got W occurring before L. We've got P occurring before both G and S. And then we've got neither G, S, nor T can be 2 or 3, so none of G, S, or T can be 2 or 3. And we've got T can't be 6. So I've laid out a few other restrictions here. Because W is before L, L can't be on 1, and W can't be on 6. And because P is before both G and S can't be 1, and P can't be 6 or 5. Because if P was 5 or 6, how could we have both of G and S coming after it? Now, I've laid out 3 different rows here because we can create 3 different main diagrams based upon the placement of the variable t. T can't be on 2, 3, or 5, so as such, t will have to be on 1, 4, or 5, because it can't be on 2, 3, or 6. So I've got t on 1, t on 4, and t on 5. Now, G and S can't be on any of 1, 2, or 3, so they have to be on 4, 5, or 6. So when t's on 4, G and S will be interchangeable on 5 and 6. When t is on 5, G and S are interchangeable on 4 and 6. And when t is on 1, G and S could still be on any of 4, 5, or 6, of course, but W cannot be on any of 4, 5, or 6, because if it was, we'd have to have L after it, also on 5 or 6, and then we wouldn't be able to fit both G and S there. So again, if W were on 4, we might have L on 5 or 6. Let's say we had L on 5. Then you could have one of G or S on 6, but you wouldn't be able to fit both of them. So for that reason, W will have to be on either 2 or on 3 in the top diagram, and this right here is our initial setup for the game. So question number 1 is a typical orientation question. We just want to take one rule at a time and apply that rule to all 5 choices, looking for violations. So we could take the rule, for example, that W has to go before L, scan through all 5 choices looking for violations, and we find that choice C violates this, having L before W. We could take the rule that T cannot be on 6, and using that rule, we find that choice B violates it, having T on 6. We could also look for P going before both G and S, and we find that choice A violates this, having G on 1 before both P and S. So for that reason, A is gone. Down to D and E, we see that, we have to have, of course, none of G, S, or T on 2 or 3. Choice E has T on 2, unacceptable, so E is gone, leaving D by elimination for number 1. Next, number 2, if none of G, S, or T were on 4. So the second and third diagram here are irrelevant because they have T on 4 and G or S on 4 respectively. So as such, we're going to have the diagram with T on 1, and then we're going to have both G and S on 5 and 6 as a result. So things aren't fully determined here, but we get quite a bit done. And scanning through the choices, of course, D, T on 1, actually fits. So it's our answer for number 2. I will look at the other choices though. A with G on 5 doesn't work because, of course, G and S are always interchangeable. For that reason, both A and C are gone. There's no particular reason we need to have one of them in a particular slot because the other is always just as good. Also, we can look at B and E, of course. P on 3 is not a requirement because P could be on maybe 2 or 4. So for that reason, B is gone. Then looking at E, W on 2 isn't required because W could still be on 3. So E is gone, leaving D by elimination for number 2. Next, number 3, general must be true question. So simply run through the choices, looking to eliminate what does not necessarily have to be true, or if you see what must be true, of course, just pick it. So running through the choices, L earlier than T is certainly not a must because we could have T on 1, which of course would require L to come after it, so A is gone. We could look for P earlier than L. Is that a must? Well, I could make a diagram where P is not before L, rather where we have L before P. If W was on 1, if W was on 2, we could have L on 3, P on 4, and then G and S on 5 and 6 interchangeable. So for that reason, we don't need to have P before L, and B is gone. Next, choice C, T earlier than G is not a must because we could have T on 5, G on 4, S on 6. So for that reason, C is gone. Next, looking at D, T before W, is that a must? No, if T was on 4 or 5, we'd have W certainly coming earlier than it. So for that reason, D is gone, leaving E by elimination. And then, of course, if we look at E, W before G, that has to be the case because W is always on one of the first 3 slots, and G is always in one of the last 3 slots. So for that reason, we always do have to have W before G, making E our answer for number 3. Next, number 4. This is like a partial orientation except question, where we want to find the choice where we can't have those 3 things occurring on spaces 4, 5, and 6. So we know that we've always got to have both G and S occurring on 4, 5, and 6 because they can't be on any of 1, 2, and 3. So any choice for A through E that does not have both G and S listed must be wrong. Now you see that choice E has only one of G or S, not both, so that's our answer for number 4, and then of course A through D all do have both G and S listed. So E is our answer for number 4. Next, number 5, if neither G nor S was 6. So we're getting rid of G and S in the bottom 2 diagrams, of course. We're looking only at the top one, where we do not have both either G or S on 6, which means that we're going to have G/S on 4 and S/G on 5. Now we're going to have P going before both the G and S, as is always the case. So for that reason, we're going to have P interchangeable with W on 2 and 3, and for that reason, L will have to be on 6. So scan through the choices, what must be true? Of course, L on 6 is a must right here, and is our answer to number 5, so B is our answer. I will look at the rest though. G on 5 is not a must because of course G and S are always interchangeable, and A is gone. Looking at C, P on 3, no, P could also be on 2, so C is gone. Looking at D, T on 4, no, T is on 1 in this scenario, the other 2 were eliminated, so D is gone. And then E, W on 2, of course, W and P are interchangeable on 2 and 3, so E is gone, leaving B as our answer for 5 by elimination as well. Next, number 6, this is a rule substitution question. So we are looking for a rule that would have an equivalent impact to the original rule that T could not be on 6. So which answer choice would establish that T could not be on 6 as well, be no more limiting than the original rule, and of course no less limiting. So something that has a precisely equal impact. So looking at A, T before G, S, or both. So we already knew it. We're getting rid of the rule that T is on 6, and would the new rule establish that T could not be on 6? Yes, if T was before at least one of G or S. Would that make T not on 6? Yes, of course, it would establish that T could not be on 6. Would it do anything aside from that? Would it do anything more limiting than that? Well, we see here on the top scenario, of course, T's before both of them because T's on 1. When T's on 4, it's before both of them. And when T's on 5, it's before exactly one of them. So yes, T's having a perfectly equivalent, A is having a perfectly equivalent impact and is our answer for number 6. I will look at the rest though. B says T immediately before either G or S. Well, that's not equally limiting. It would be in the second and third diagrams here, but in the top one, it's before W or P, and then of course, G and S are coming much later on 4, 5, or 6. So for that reason, B is too limiting, not equally limiting, B is gone. Next, looking at C, T is before L. Would T before L have an equivalent impact? No, because in the second and third diagrams here, T is not before L at all. L is earlier than it, so for that reason, C is gone. Next, looking at D, if T was not first, it must be immediately before G. So if T is not 1, then T is immediately before G. Is that equivalent? No, it's actually much more limiting, because in the second and third diagrams here, where T is not on 1, T is immediately before G or immediately before S. So by limiting it to G in particular, it's too limiting and D is gone. Then looking at E, either G or S is on 6. That of course is the case for the second and third diagrams, and of course that is establishing that T would not be on 6 in those diagrams. But then in the top diagram, we don't have to have either G or S on 6. Perhaps we could have L there. So for that reason, E is too limiting by saying that L could not be on 6 in the top diagram, and as such is eliminated. Remember that we saw it in question 5, we could have L on 6. So E is too limiting, is gone, leaving A by elimination for number 6 if you didn't get it before.